Hello everyone. Hope you all are doing good. As you all might have known that I will be taking the classes of your course microprocessor and microcontroller. So, let me discuss very briefly the syllabus of microprocessor and microcontroller. So, I'll be teaching you the basics of microprocessor, its history and evolution. Then everything related to 8085 microprocessor like its architecture, instruction set, timing diagram, etc. Everything related to 8086 microprocessor, the data transfer techniques, and 8051 microcontroller. So let's start the course. The microprocessor acts as the brain of a digital computer system. Before going into the detailed description of a microprocessor, let us have the basic knowledge of a digital computer. A computer can be defined as a programmable machine which can make calculations, manipulate, measure, store and display information, control, process, equipment, machine and appliances, transmit and receive information, and so on. The main components of this digital computer are central processing unit, memory, input device, and output device. Here, the central processing unit executes instructions. The input device is used to feed programs and data to the computer. The memory is a storage device. It stores programs, data, and result. The output device displays or prints programs, data, and results according to the instruction given to the computer. So this central processing unit built on a single integrated circuit is called a microprocessor. A digital computer in which one microprocessor has been provided to act as a CPU is called microcomputer. A desktop computer and portable or mobile computers like laptops, notebook, palm top, etc. contain one microprocessor to act as a CPU, and hence they come under the category of microcomputer. The CPU of a large, powerful digital computer contains more than one microprocessor. For example, supercomputers, high-end powerful servers, etc. These microprocessors placed in a CPU of large powerful computer operate in parallel. So such type of computers are known as multiprocessor computer system. Now, microcontrollers. Microcontrollers are the microprocessors designed specially for control applications. So it is a silicon chip which includes microprocessor, memory and input-output in a single package. Microcontrollers, are otherwise called as embedded controllers, are generally used to control and operate smart machines. Some of the machines using microcontrollers are microwave ovens, washing machines, sewing machines, automobile ignition systems, etc. Out of 100 processor chips manufactured, 99 are embedded processors and remaining one processor alone goes into general computers. So this is the block diagram showing microcomputer, microprocessor and microcontroller. So now coming to the main point, what is microprocessor? The word comes from the combination micro and processor. Processor means a device that processes whatever. In this context, processor means a device that processes numbers, specifically binary numbers, zeros and ones. To process means to manipulate. It is a general term that describes all manipulation. Again, in this content, it means to perform certain operations on the numbers that depend on the microprocessor's design. Micro is a new addition. In the late 1960s, processors were built using discrete elements. These devices performed the required operation but were too slow and too large. In the early 1970s, the microchip was invented. All of the components that made up the processor were now placed in a single piece of silicon. The size became several thousand times smaller and the speed became several hundred times faster. The microprocessor was born. So the microprocessor is a programmable device that takes in numbers, perform on them arithmetic or logical operations according to the program stored in memory, and then produces other numbers as a result. Let's expand each of the underlined words. So starting with programmable device, what is actually programmable device? The microprocessor can perform different sets of operations on the data it receives depending on the sequence of instructions supplied in the given program. By changing the program, the microprocessor manipulates the data in different ways. Next, what is instruction? Each microprocessor is designed to execute a specific group of operations. This group of operations is called an instruction set. This instruction set defines what the microprocessor can and cannot do. So the next underlined word is takes in. So this means here the data that the microprocessor manipulates must come from somewhere. It comes from what is called input devices. These are devices that bring data into the system from the outside world. These represent devices such as keyboard, mouse, switches, etc. The next underlined word is numbers. So here the microprocessor has a very narrow view in life. It only understands binary numbers. A binary digit is called a bit. The microprocessor recognizes and processes a group of bits together. This group of bits is called a word. The number of bits in a microprocessor's word is a measure of its abilities. The earliest microprocessor, the Intel 8088 and Motorola 6800 recognized as 8-bit words, they processed information 8 bits at a time. That is why they are called 8-bit processors. They can handle large numbers, but in order to process these numbers, they broke them into 8-bit pieces and processed each group of 8 bits separately. Later, microprocessors 8086 and 68000 were designed with 16-bit words. A group of 8 bits were referred to as a half word or byte. A group of 4 bits is called a nibble. Also, 32-bit groups were given the name long word. Today, all processors manipulate at least 32 bits at a time, and there exists microprocessors that can process 64, 80, 128 bits. The next underlined word is arithmetic or logical operations. Every microprocessor has arithmetic operations such as add and subtract as a part of its instruction set. Most microprocessors will have operations such as multiply and divide. Some of the newer ones will have complex operations such as square root. In addition, microprocessors have logic operations as well, such as AND, OR, XOR, shift left, shift right, etc. Again, the number and types of operations define the microprocessor's instruction set and depend on the specific microprocessor. The next underlined word is stored in memory. First, what is memory? Memory is the location where information is kept while not in current use. Memory is a collection of storage devices. Usually, each storage device holds 1 bit. Almost in most kinds of memory, storage devices are grouped into groups of 8. These 8 storage locations can only be accessed together. So one can only read or write in terms of bytes to and from memory. Memory is usually measured by the number of bytes it can hold. It is measured in kilos, megas, and lately gigas. A kilo in a computer language is 2 to the power 10, that is equal to 1024. So a kilobyte is 1024 bytes. Mega is 1024 kilobytes and giga is 1024 megabytes. So when a program is entered into a computer, it is stored in memory. Then as the microprocessor starts to execute the instructions, it brings the instructions from memory one at a time. Memory is also used to hold the data. The microprocessor reads the data from the memory when it needs it and writes the result into the memory when it is done. And the last underlined word here is produces. Here it means for the user to see the result of the execution of the program, the results must be presented in a human readable form. The results must be presented on an output device. This can be the monitor, a paper from the printer, a simple LED, or many other forms. So from the above discussion, we can draw the following block diagram to represent a microprocessor based system. The major components of a microprocessor are, or you can say CPU are arithmetic and logic unit, timing and control unit, and registers. So, what does an arithmetic and logic unit do? So, here I have expanded the picture a little bit. You can see ALU register array control making the microprocessor. This is the memory, again a separate box, and input output devices in other box, and all these are connected through system bus. Since I have told you that microprocessor consists of ALU register array and control, let me explain each in detail. So ALU is arithmetic and logic unit, and ALU perform arithmetical and logical operations. Arithmetical operations performed are addition, subtraction, multiplication and division. In addition to these operations, it also takes complement of a number, it compares two numbers, rotates the bits of a number left or right, increments or decrements the number, etc. The next is control unit, or you can say timing and control unit. The timing and control is responsible for working of all other parts of the microprocessor together. It maintains the synchronization in operation of different parts in the microprocessor. The synchronization is achieved with the help of one of the timing and control logic's major external inputs, that is microprocessor's clock. The clock is a signal which is the basis of all the timings inside the microprocessor. Then the register, here registers include accumulator, general purpose registers and special purpose registers. The accumulator is a register which contains one of the operands of an instruction to be executed. It also stores result after the execution of an arithmetic and logic instruction. General purpose registers are used to store data and hold intermediate results while executing a program. Getting the operand from the general purpose registers is more faster than from memory. And the last one, special purpose registers are used by the microprocessor itself. They are not accessible to users. Example, program counter, stack pointer, instruction register and status register, etc. So all these registers you will be dealing in detail when I will be teaching you 8085 microprocessor. So the next is, how does a microprocessor works? The microprocessor follows a sequence: fetch, decode and then execute. User's program is stored in the memory. The CPU fetches instructions of a program from the memory sequentially. It fetches one instruction at a time, decodes it and then executes it. After decoding an instruction, the CPU comes to know what operations are to be performed. It also comes to know whether the data to be processed are in the memory, general purpose registers of the microprocessor, or at input-output ports. If data are in the general purpose registers, the CPU executes the program. If the data are in the memory or at the input-output ports, it reads the data from the memory or input-output port. Then it executes the instruction and stores the intermediate results. After completing the execution of one instruction, the CPU fetches the next instruction of the program. In this way, CPU fetches and executes all the instructions of a program and gives final result. So till this point only I have taken this class. From the next class we will continue